Today we have a special guest. We have Maia McGuire, and she is the Sea Grant Coordinator for the University of Florida. Fill out the rest.
Cooperative Extension Program.
Cooperative Extension Program. And here we're here today to talk about global warming and weather trends and a lot of things, and that's what you're really looking at. Probably let's start off with the first thing and get it right out on the table. There's been some controversy. Is it global warming? Are we just in a weather pattern, or is it a trend? And I guess there's been some recent decisions among the scientific community that kind of decided the issue. Tell us about it.
Right. There was a group that meets every few years or so. They're called the Intergovernmental Panel on Climate Change, affectionately known as the IPCC. They released their last report their most recent report in 2007. And basically what this is, it's a panel of scientists from all around the world that get together and they review all of the new published literature that's come out since their last meeting. And as a group, they take a look at what new data have been presented, what trends are coming out by looking at all these different reports together. And for the first time in 2007, they stated that not only did the data support the fact that there is a process going on of climate change, but that there are actually sufficient data to show that human activities are increasing the rate of climate change.
What's the difference between global warming and climate change, or is it just semantics?
A lot of it is really semantics. We started off as people were noticing increases in air temperatures, increases in sea surface temperatures. Somebody coined the term global warming. But then as we started doing studies and measurements of climate in different parts of the world, scientists realized, well, things aren't warming everywhere. There are certain sort of pockets where the trend is actually that there are cooling temperatures happening. And so
we had one a couple weeks ago.
Well, that's weather. That's a short term,
okay.
Very, very short term. But when we look at trends over the long term, what we see is that some places are actually cooling, other places are warming. And so scientists decided maybe using the term climate change rather than global warming was a more accurate description and might help get over some of the perceptions of, we've just had a really cold winter, how can global warming be happening? So that's sort of the reason for the change in the terminology.
What are some of the expected impacts from this? I mean, we hear about melting ice, we hear about sea level changes, that sort of, what can we expect?
Well, as a marine biologist, obviously I focus on what's likely to happen in coastal areas or in the ocean itself. And there are several trends that have already started that we expect to continue. Probably one of the ones that comes to people's minds first, as you mentioned, is sea level rise. Another factor is warming ocean temperatures. Again, as I mentioned, we seem to have annual sea surface temperatures that are increasing over time. There's a process called ocean acidification, which is tied to really greenhouse gases like carbon dioxide. What happens is the carbon dioxide that's in the atmosphere actually gets dissolved by the ocean, and the ocean has a buffering capacity. Basically, it has a lot of dissolved stuff in it that acts like a Tums does in our stomach. So when we add acid to our stomach, it gets neutralized by the Tums, the carbonate that's in there. The oceans function like a giant stomach with a lot of Tums in it. So that CO2 that's in the atmosphere gets dissolved.
You've ruined my aspect of looking at the ocean now.
The CO2 in the atmosphere gets dissolved in the water and forms an acid, but then the ocean can kind of balance that out. But it has a finite capacity to be able to buffer. So we are seeing that over the last 150 years or so, the pH, the measure of acidity in the ocean, has actually declined over that short time period. And we expect that trend to continue because of the amount of carbon dioxide that's in the atmosphere.
Well, I guess the major concern in Florida is sea level. What really contributes to sea level rise? I mean, we're not on any mountaintop here. We're pretty close to sea level.
Yeah.
Most of the county, I believe, is at sea level. And there's a few ridges, old dunes and everything, but what makes the sea rise, basically?
There are several factors, and this is one of the reasons that it's very difficult to predict how much sea level rise is going to occur over what time period, because the different factors have different controls to them. So the main thing that people are aware of is that when you heat water, it expands.
Right.
So if we are increasing atmospheric temperature, we're going to be increasing water temperature, and the volume of the ocean is just going to increase, which will make the sea level rise. A second factor is melting ice. Now, this is melting of ice that's currently on land as opposed to ice that's in the water, because if you think about it, when you have an ice cube in your glass and it melts, the level in your glass doesn't change.
Right.
But if you have an ice cube sitting on a spoon raised above your glass and it melts and you
Drips
pour it
into
in there, then it'll rise. So the ice that's on land in the poles, as that is melting, that contributes also to sea level rise. And then there's a third factor, which has a lot of geographic variation to it. In places like Louisiana, where there is fairly loose materials making up the rock, when you draw things out from underground like oil, those loose sediments can actually settle down where the oil used to be, and it's what we call subsidence. And so the ground can actually become lower, which in effect makes the sea level higher. Other parts of the world, like there are places in Washington State where the land is actually increasing in height because of plate tectonics. You've got one plate diving underneath another, and it actually pushes the land up. So those land shifts are another factor that contributes to sea level rise and the effective rate of sea level rise.
What can we expect? I mean, should I move, or should we,
Well, the average sea level rise for the 20th century has been a little less than 2 millimeters a year. So that doesn't seem like a lot, but when you look at it over 10 years, it's about an inch, a little less than an inch. Over 100 years, something less than a foot. However, in the last 15 years or so, the trend seems to be more rapid. It's more like 3 millimeters a year, which again is a tiny amount each year, but over a 50-year, 100-year time span, it adds up. And because we are so close to sea level, when we have an inch of sea level rise, the net effect on, say, on a beach, it's not just going to move high tide an inch up the beach, because we've got a very gentle slope. So it could actually be a matter of a couple of feet that the high tide mark would move up a beach.
Would also affect water aquifers and that sort of thing. Where
it does, and that's a huge problem in Florida. We have already an issue for our farmers here in Flagler County, where they are recording high salt levels coming out of their wells. And of course, that's no good for irrigating crops. The reasons for that are probably twofold. One is, as we take fresh water out of the aquifer, if we're withdrawing it faster than new water's coming in, then we get a little bit of a sort of vacuum situation in the aquifer. And because our limestone rock is very porous to water, it will actually, that vacuum will sort of pull salt water in underground to fill that vacuum. The second factor is, as sea levels increase, we have more head pressure, more weight of seawater pressing down and forcing water through those porous rocks and into aquifers. So it's kind of a double whammy there.
It's kind of a balance out there between the fresh water and the seawater, and if seawater rises, it pushes
Right, and seawater's heavier than fresh water, so it tends to come in the bottom of the aquifer, and as we're drawing water out, it will kind of get sucked up towards the wellhead, and then the well will end up pulling up brackish water and then increasingly salty as more water is withdrawn.
Scientists concluded that people are contributing to this problem. What is it that we can do individually?
It's really easy for people to say, well, I'm just one person, I can't make a difference. But we've all contributed to the problem in the first place, so anything that we can do to reduce our greenhouse gas emissions, that's the big push right now. Try and reduce those levels of CO2, try and reduce our fuel consumption, try and reduce our noxious emissions. Simple things that people can do: conserving energy. Everything from changing your thermostat by a couple of degrees,
turning off lights,
cooler in the winter, warmer in the summer, turning off lights, putting in a programmable thermostat in your house, changing your lights to compact fluorescent bulbs instead of incandescent bulbs.
Programmable thermostats, great invention. I've got one at my house for the first time, and it's a neat thing. It really works well.
Yep, and you really can save a lot of money. Actually, I added on to my house about 2 years ago and added on about 30 or 40% more square footage to my house. And was kind of curious to see what would happen with my electric bill, but at the same time, I replaced the windows in my house, changed out all the light fixtures to the compact fluorescent bulbs, and I haven't seen a change in my electric bill with that added square footage. So it really does make a difference to do all these little things. It saves you money, and oh, by the way, we're helping protect the environment and helping reduce our carbon footprint or our emissions.
We built a new house quite some time, not new anymore, but out on the west side, and we paid attention to what we were doing as far as insulation and windows and everything, and we were totally amazed. The old cinder brick house we lived in was about, in the wintertime, it'd be $250. This house is $85, and this house is bigger. So it's amazing. Just a few changes, a few things that you watch. Make sure you get good windows, make sure you've got plenty of insulation, the compact fluorescent bulbs. We've saved a bunch of money just on electric bill, so that does help.
And there's another really important thing that people can do, and that is conserving water. And you don't tend to think about conserving water in association with climate change, but really everything that we do is connected. Our water consumption is connected to our aquifer levels. Even if you have a well that you're using for irrigating your yard, it's drawing from a shallow aquifer.
Right.
And there's only a finite amount of water on our planet, and it all gets recycled and recirculated.
Right.
So that's another way that we can save ourselves money, but also help protect the environment by just reducing your shower time, not irrigating unless you have to, changing your irrigation methods. So there are various things that we can do in our homes to make a big difference.
I understand that you've studied coral. And
yes.
Is global warming or climate change affecting the coral?
It is, and it's expected to have a really huge impact. We've already got a lot of things going on in our coral reefs that are having negative impacts. We have disease outbreaks that we don't understand the causes of. With warming temperatures, we've seen increasing phenomenon called coral bleaching, which is a stress response of the corals, where they basically lose their partnership with an algae that normally lives inside the coral animal cells. And that sometimes the corals can recover from that, and sometimes they die after that.
Right.
The ocean acidification is expected to have a negative impact, and actually if you combine acidification and increased temperatures at the same time, you have a worse impact from some experimental studies than either one of them alone, or just adding the two together would be expected to have. There are other things. Acidification is also going to impact pretty much anything that has a shell. So crabs, lobsters, clams, oysters.
All my favorite foods.
And the things that they feed on, the plankton. There are actually plankton that have a calcium carbonate shell on them. And as the ocean's pH decreases, it's expected to have a negative impact on those creatures, especially things like baby crabs and clams that have very, very thin shells. Wouldn't take much to dissolve them. And so there are a lot of question marks relating to coral reefs, but there really isn't a lot of positive data out there.
This is all doom and gloom. Is there any good news for coral?
There is one bright spark for corals. We've found in recent years that there seems to be some range expansion going on for some coral species. Basically, right now, corals are limited to between a certain latitude and longitude because of water temperature, water clarity, and so on.
More in the Keys than here, that kind of thing.
Right.
More tropical.
Right. There's a coral reef in the Gulf of Mexico, in the northern Gulf of Mexico. It's the northernmost coral reef in the United States. And it historically has not had, at least in recent history, hasn't had the big branching corals, the elkhorn and staghorn corals that we see a lot of in the Keys.
Right.
In recent years, they've actually discovered 2 colonies of elkhorn coral growing in that area. And there has been some thought that perhaps warming water temperatures are allowing elkhorn to survive now in the Flower Gardens banks where they weren't previously able to survive. So it may be that some corals are able to find a refuge in some new areas and survive this warming trend, and then in the future, as things hopefully cycle back to what we consider normal, they would be able to recolonize the areas where they live now.
That's good. Very good. Thank you. Good news. Some good news.